Hello, this is Paul from Portal Tech. In this video, let's prove Theorem 3.5.3. We call the area of a parallelogram. And the theorem states that the area of a parallelogram in three space, okay, is just equal to the area, equal to the norm of the cross product of the two sides, okay. Which is so good, right? So how do you find the area? You just find the vector of this u, find the vector of this v, and then you find the cross product of u cross v, and the distance or the norm of it, which is the area. So the same. The statement is the same as this equation. YC. The right side is the way that we calculate the area of the parallelogram, right? Because the norm of v here and the project, okay. So therefore, this side, therefore the height of the parallelogram, which is the norm of v times sine theta. If the angle here is theta, this is the height, and then what the base of the parallelogram is u. So therefore, u times the base times the height is the area. So it's the same. Why? This is true. Let's see why this is true. Okay. It's not difficult to prove. We need the Lagrange's identity. Okay, so we learned before in Theorem 3.5.1. Remember that. Okay, so all we need is a little bit. So let's see a simple proof. We can square first because Lagrange says the square of the norm of a cross product can be calculated by what the product, the dot product. Okay, see. So we can start from we start from here. We start from the norm squared, okay, by theorem 3.5.1. Lagrange's identity. Okay, remember Lagrange's identity. Just use this. Okay, one property. We can get the answer, which is the norm of u squared times the norm of v squared minus the dot product squared. Okay, see, that's a super famous identity. And now, see what do we have? I can put here u is still the u and the v is still v. I can calculate this one. Okay. The dot product, I use the definition. Okay. Link to the angle between, which is the definition give us is minus the norm of u times the norm of v times cosine at the angle between, which is a cosine theta, right? Okay, so theta is the angle between u and v. Okay, so this one is just the dot product in three space. Therefore, this one we have to square, and then we do calculation. So now square. So the first square, the second square, we can factor out the common factor. Okay, so we factor out. We factored out the common factor, which is this one, right? So this is the common factor. Okay. After we factored out, what do we left? It is first is one left. The second is also cosine squared left at theta, right? Okay, see. And the 1 minus cosine squared equals sine squared. So this one equals u times v squared times sine theta. That's what? That's Pythagorean identity, right? So Pythagorean for this term. We learned in trigonometry. Pythagorean. Okay. Is this the answer we need? No, we don't need the square, right, in this equation. So we take square root of the left, we take square root of the last expression. So we have this. Therefore, take a square root, we have u cross v. Okay, we do the square root of the last. Square root of here. So this one times this one. And because theta is the angle, theta is between like 0 to pi, okay, whatever, right? So therefore, we know sine theta is non-zero, okay, non-negative. So when we take a square root, which is the sine theta. Okay, so this is the equation, right? So we need to prove. That's all. Thank you.